In this video, I will be doing a few example problems specifically related to section 1.6 and the calculation of the different power indices therein. Let's look at problem A. Here we are given a voting system, and if we break down this voting system, we see we have a quota of 12, so 12 votes needed for a majority or for a motion to pass, and we have 5 different voters with weights ranging from 6 all the way down to 2. Now, we are given a coalition here. We are told that voters 1, 3, 4, and 5 will all be voting yes. And we want to determine if any of them are critical in the coalition. Now remember, a critical voter is one where if they were to change their vote from yes to no, then it would change from a winning coalition to a losing coalition. So how many votes does this coalition have as is? Well, voter 1 has weight 6, 3 has weight 3, 4 has weight 3, and 5 has weight 2. So these voters have a weight of 14 combined, which is greater than the quota of 12. So this is a winning coalition. Now we want to evaluate what happens if any one of those voters changes their votes. So what happens if P1 changes their vote? Well, instead of a vote total of 14, they would lose 6 votes. There would be 8 left. So with 8 votes, it's no longer a winning coalition. So this becomes a losing coalition if voter 1 changes their vote. What about if voter 3 changes their vote? So the coalition as is has 14 votes. If voter 3 changes their mind, they would lose 3 votes and only have 11. Again, that's below the quota. That's now a losing coalition. And in fact, the exact same thing will be true for P4. It would also go down to 11 because voter 4 had exactly the same weight as voter 3. And so this is now a losing coalition. And finally, we have voter 5. What happens if voter 5 changes their vote? Well, the 14 loses 2 votes for a total of 12. And so now it is still a winning coalition. They did not need voter 5, but every other voter was critical. So the ones that were critical, that if they changed their votes, it went from a winning to a losing coalition, were voter 1, voter 3, and voter 4. And the one who is not critical was voter 5, because even if they changed their mind, it would still be a winning coalition without them. So that is the important concept here of determining whether a voter is critical in a coalition. See what happens to the vote total if you remove that voter and whether it switches from a winning to a losing coalition. That is the concept we need to investigate when we are calculating the Banzhaf power index. For any individual voter, the Banzhaf power index tells us how often or what proportion of the time their vote is critical in a winning coalition. So here we're now looking at a system with a quota of 9 and with 4 different voters. And if we're calculating the Banzhaf power index, we need to find every winning coalition. Now, you can certainly start by writing out every single coalition and determining whether it's winning or not. But you can also just list out the winning coalitions. To do this, you need to find all groups of voters that if you sum their weights together, you get at least the quota, which in this case is 9. So if you look at the voters as individuals, voter 1 on their own cannot be a winning coalition. They don't have enough weight. Voter 2 on their own cannot be a winning coalition. But what about voter 1, and let's add the next voter, voter 2. 1 and 2 together, would they be a winning coalition? Well, yes, they would have 7 plus 5 votes for 12, and the quota is 9. So 1 and 2 on their own would be a winning coalition. What about 1 and 3? That would be 7 votes plus 4 votes for 11, so certainly that would still be a winning coalition. What about 1 and 4? Voter 1 and voter 4, it would be 7 votes plus 1 vote for 8 votes. This is not a winning coalition. Next, so this is all pairs. Next, let's try voter 1, voter 2. Clearly, anything else we add to this, it will still remain a winning coalition, right? We could add voter 3 and it would still be a winning coalition. We could add voter 4 and it would still be a winning coalition. And we could add both voters 3 and 4 and it would still be a winning coalition. And the only one I believe that's missing at the moment is if we start with P1 and P3, we could also add P4 and it would be a winning coalition. If I also considered adding P2, that would be a valid winning coalition, but it's one that we already listed previously. So you don't want to double up here. So all of these have P1 in them. Can we construct a winning coalition without P1? Well, what about P2 and P3 on their own? Would that be a winning coalition? 5 plus 4 is 9. That would meet the quota. So we can also add an extra voter to this, P4. It would still be a winning coalition. What about P3 and P4? Again, that would be 4 plus 1 or 5. That would not be a winning coalition. So these are all the winning coalitions. And now we want to determine in each of these, if we list out the voters, P1, P2, P3, P4, we want to determine whether they are critical in each coalition. So I'm going to sum up all the weights here. 1 and 2 together have 12 votes. 1 and 3 together have 11. And I'm just going to hit pause here for a minute and fill out all the vote totals. Okay, so you'll see the totals on the left have now been filled out. I know how many votes each coalition has. And now I want to ask myself, with this first coalition, P3 and P4, of course, here are not relevant to this coalition. If I remove P1, is it still a winning coalition? If I take away 7 votes, no, it's not. So P1 would be critical. If I take away P2, is it still a winning coalition? Well, if I remove 5 of the 12 votes, I'm now below 9, so it's no longer a winning coalition. What about P1 and P3? If I remove the 7 votes from P1, 11 minus 7 would now be below the threshold of 9. Both P1 and P3 in this case are critical. P2 and P4 are not relevant. What about P1, P2, and P3? If I remove P1, those 7 votes, I still have 9 votes left. Like if I take the 16 and I remove 7, if I take the 16 and I remove 7, I still have 9 votes left. So P1 is not critical here because P2 and P3 would still be a winning coalition. If I remove P2, P1 and P3 would still be a winning coalition. And if I remove P3, P1 and P2 would still be a winning coalition. So no voter is critical in this coalition. Any one of them can change their minds, and they would still have a winning coalition with the remaining 2. What about P1, P2, and P4? Well, here, if I remove P1, so I have 13 votes. If I remove 7, I'm left with 6. Would that still be a winning coalition? No. So here, P1 is critical. What about P2? If I have 13 and I remove 5, I have 8. That's below the quota, so P2 is critical. P3 is not relevant, and P4 has 1 vote. If I have 13, I remove 1, I still have 12, so P4 is not critical here. So we're just doing this for each possible coalition. The coalition of P1, P2, P3, and P4 with all the voters in it. 17 votes. I can remove any one of them, and the remaining 3 will still have a winning coalition. So no one is critical here. You can see, you take the 17, you subtract out the weight from any one of those 4 voters, and it will still be a winning coalition. What about P1, P3, and P4? 12 votes. If I remove the 7 of voter 1, it becomes a losing coalition, so P1 is critical. 3 is also critical because if I remove the 4 votes, I only have 8, so can't function without P3, but P4 is not critical. If I remove that 1 vote, we still have a winning coalition. Next one, the P2, P3, both of those end up being critical. Please make sure you check the math on that. And in the last part here, P2 and P3 are each critical, but P4, if I remove that 1 vote, it still remains a winning coalition. So P2 and P3 are critical, but P4 is not. Okay, so to get to the Banzhaf power index, we calculate the individual power of each voter, which is just how many times it is critical to a coalition. How many times is P1 critical? Shows up 4 times. How many times is voter 2 critical? Voter 2 shows up 4 times as being critical. Voter 3 shows up 4 times, and voter 4 shows up 0 times. So those are my Banzhaf powers, but it's not the power index yet. I first calculate the total Banzhaf power, and that is just the sum of all of the individual power values. So in this case, that is 12. Then I can go and calculate the Banzhaf power index for each individual voter. And the index is given by the individual power. So for voter 1, that's 4, divided by the total power, multiplied by 100 to make it a percentage. And this would be 33.3%. And if we do the same thing for P2 and P3, they will both as well have a Banzhaf power index of 33.3%. But voter 4 this voter has a bonds of power index of 0%. But there you have a breakdown of how you calculate the bonds of power index in each instance. Our next example now moves on to looking at permutations of voters. So here we have a voting system with 7 voters. It has a quota of 60, and we are given a specific permutation of voters. What this means is we want to find the point in that system where the pivotal vote is cast. For example, the way it's set up, if just P2 votes yes, there would be 21 votes in favor and everything else would be against. If both P2 and it would be, for P2 it would be 20 votes. If P2 and P3 vote yes, there would be a total of 31 votes. Still not enough. P5 adds another 9 votes. That would get us to 40 votes. Still not enough to pass. If we add P7, that would add another 4 votes. We're now at 44 votes. Still not enough. P1 would add another 21 votes. That would bring us to 65. So this is the point where we exceed the quota. In this specific permutation, if we take them in the order in which they're listed and we just add consecutively how much weight each voter brings to the system, then in this order, the voter who puts us over the edge, changing it from a losing coalition to a winning coalition, is P1. So in this ordering, P1 is pivotal. And in any permutation, only one voter can be pivotal because you're looking for that point where the coalition changes from losing, and then when you add that specific voter, they have enough weight to make it a winning coalition. So this is a central calculation to the Shapley-Shubik power index. We list out every possible ordering of voters, and then we determine for each ordering who is the pivotal voter. So because there are usually a large number of permutations, we're typically only going to do this calculation by hand with 3 voters or maybe 4 voters. So in this example, we have a voting system with a quota of 5 and 3 voters with weights 4, 3, and 1. And I created a table here listing out all the possible permutations. So what we want to see is at what point do we exceed the quota? So if just voter 1 votes yes, we would have 4 votes. If voter 2 also adds their weight, we would add 3 and we would be at 7. That would be the critical or the pivotal vote in this instance. So in this permutation, P2 is pivotal. What about if we start with P1, we would have 4 votes. P3 would add another 1. So that would get us to 5. So in this permutation, P3 is the pivotal voter. If we started with voter 2, we would have 3 votes. If voter 1 was the next one in sequence, that would add 4. That would get us to 7. So in this permutation, P1 is pivotal. What about if we start with 2, who has a weight of 3, we add the 1 from voter 3, that would get us to a weight of 4. That's not enough yet. So we have to take voter 1 into consideration as well. they would add a weight of 4, which would get us to 8. That finally puts us above the quota. So in this case, P1 is pivotal. If we start with voter 3, we would have a weight of 1. If voter 1 is next, they would add 4. That would get us to 5. That's all we need. So voter 1 is pivotal. And finally, if we start with 3, we would have a weight of 1. If 2 is next, that adds 3 to the calculation. That would give us a total of 4, which is not enough yet. We need voter 1's votes as well to put us above the threshold. So, voter 1 is pivotal 4 times, and voters 2 and 3 are only pivotal 1 time. Now, to calculate the power index here, we need to calculate how many permutations there are. Remember, a number followed by an exclamation point means you take that integer, you keep on subtracting 1, and you multiply all of those integers together. So in this case, 6. And this is another way to check your math. This total, or this number of permutations, should be the same as the sum of these numbers. 4 plus 1 plus 1 is 6, so that checks out. So the Shapley-Zubrick power index for each voter now is how many times they are pivotal divided by the number of permutations. So for P1, it would be 4 out of the 6 times, which means in this case, 66.7%. That's their power index. And for P2, it would be 1 out of the 6 times. That in this case would be 16.7%. And exactly the same thing would be true for P3. 1 out of the 6 times. So 16.7%. And during our live session tomorrow, we will do plenty more examples of each of these power index calculations.